So hi everyone, welcome. In this part, we'll discuss the two crucial concepts in object-oriented programming, the encapsulation and inheritance. These concepts are the building blocks of designing clean, secure, and reusable software. I'll walk you through examples from our system, the Tourist Hikers Management System, to explain how encapsulation protects data, while inheritance reuses code efficiently. Imagine how these concepts would work in our system as I guide you through the code. So without further ado, let's dive in. In our program, the tour class has private variables po like this. As you can see here. Yes, these variables po are marked private, meaning they cannot be accessed directly from the outside of the class. This protects them from being accidentally or intentionally modified. Now, to interact with these variables po, we use the getter and setter methods po. Here's what's happening po. Here, example po, this is string method or this public string get tour code method po allows us to retrieve the value of tour code in a controlled and read-only way. Second po, yung set capacity. This one not only sets the capacity but also ensures that remaining capacity is updated correctly. This keeps the two fields consistent. Imagine po you're using the system na sa terminal. You're booking a tour in this system. You selected a tour in the system po. When you book a spot, the system po doesn't allow you to directly modify the remaining capacity field. Why? Kasi po yung method na to ensures that yung remaining slots decreases only if there are slots available. Kasi if there are invalid changes po like setting the remaining slots to a negative number, it will prevent po. After you book, the system will automatically update the remaining slots. This control over how data is accessed and modified is the essence of encapsulation. Now, if we talk about the matters of encapsulation, encapsulation po is critical for several reasons. Actually, three. First is the security. Sensitive fields po, like yung example nga, yung tour code and capacity are protected. Second po is validation. You can enforce rules when setting or updating fields. For example, ensuring capacity is never negative. Tapos, lastly po, maintainability. By hiding the internal implementation, you can change how the class works internally without affecting other parts of your program. To sum it up or conclusion, encapsulation creates a clear boundary for how an object state can be accessed and modified, making your code more robust and easier to manage. Now, let's move on po sa inheritance, another fundamental concept in the OOP. Inheritance allows us to define a parent class with shared behaviors and let child classes reuse those behaviors. This makes our code modular and prevents duplication. As you can see po in our program, we have an abstract class called manageable entity. This one, yes. The manageable entity po acts as a blueprint for other classes like yung hiker. It defines methods that every child class must be implement. Where's the hiker class? This one. Now, the display info po, this one, is used to print details about an entity, while yung search by name po methods helps locate an entity by its name. The hiker class, this one, inherits from the manageable entity but adds more functionality by implementing the searchable interface. Here's what's happening here po. Yung the hiker class po implements the display info and search by name methods. By inheriting from the manageable entity, we avoid rewriting shared logic This is a great example of code reuse. Now, if you imagine po, you're using again the system sa terminal, and you are searching or naghahanap ka ng specific hiker in the system. The program runs the search by name method in the hiker class and finds the hiker that matches, then it calls display info. This is an example of this is also an example po of polymorphism where the same method name behaves differently based on the object it belongs to. Now, if we talk about inheritance po, inheritance is powerful because of these three reasons. First is code reusability, obviously. Shade behaviors po, like display info and search by name are defined once in the parent class and reused in child classes. Second po, yung consistency. Every class po, inheriting from manageable entity follows the same structure, making the program predictable. And lastly po, extensibility. If we need a new entity like a guide, we can create a new class that inherits from the manageable entity without starting from the scratch. By using inheritance po, we make our program modular, easier to understand, and scalable.
Hi everyone! Since John Paul Caldo has already discussed the two pillars of object-oriented programming, which are the encapsulation and inheritance, I am here to discuss the last two pillars, which are the abstraction and polymorphism. Let's start with the abstraction. Contextually, abstraction is used to simplify the representation or interaction with complex data by hiding the implementation or the process, how it works, and exposing only the relevant functionality. You can also refer that as a prototype, which you can only see the output and not the process inside. Then it usually answers the question what and not the question how or how it works. Here in our code, we have here an abstraction, which is an abstract class to define common behavior that has the display info and search by name. The display info and search by name is inside the class manageable entity, and once you call this abstract class, you can access the content, which are the display info and search by name, and from the word display, it simply display what you, or it will simply display the info that you are asking for. And here in search by name, it also display the search name that the user is searching. And we have here encapsulation and abstraction in tour. It is the combination of encapsulation and abstraction. Here we have static class tour extends manageable entity. When we use the extend method, it is simply to denote that you are going to use the attributes from the subclass or from the abstract class, which is the manageable entity, and the attributes from manageable entity are asked by the tour subclass. Since it uses extend, it is likely to define some generic behavior or structure for entities can be managed. Either it can be searched or displayed, since from manageable entity we have the display info and search by name. And since we're using abstraction, we are literally hiding the implementation details of that specific subclass. Or for example, we have here the tour. We have here the tour subclass or the tour class, which declares private fields such as tour guide, tour code, name, capacity, and remaining capacity. And these fields represent the internal state of tour but not directly accessible by external code since the class is private. It is set here that if you want to use those attributes or those functions from a private class, you have to use the setter and getter from the encapsulation. And once you have implemented the setter and getter, you can now access the functionalities that you need onto the private class. Then the abstraction is simply implemented by the user since it interacts with the tour's attributes through a controlled interface, which we have the setter and getter, without needing to understand how attributes are sorted or updated internally, since you are just seeing the display or you are just seeing the output, not the process on how it works. We have here the inheritance and abstraction in Hiker, which the Hiker extends manageable entity. Since the Hiker extends the manageable entity, Hiker can now, or the Hiker class can now access the functionalities within the manageable entity. And we have here the string name, integer, string tour code, and contact number. And this part also uses getters and setters, which is from encapsulation. The last part that we use, the abstraction, is for displaying tours and Hiker, which we have the private class for view tours. Then we also have here the polymorphism via abstraction, but the abstraction part here is the display info, which literally will display the information or the tour list that is asked here. Also here, we used an abstraction for view all hikers, which simply to view the hikers, and also uses polymorphism via abstraction for displaying the info. And that's all for the abstraction. Let's move on into the polymorphism. Polymorphism allows methods to behave differently based on the object that is invoking them. In this code, we have the search by name and display info methods are overridden in the tour class, providing implementations to specific tours. Tour class, not only tour class uses the override method, since it also used by the hiker to display info from manageable entity class. Then override is a method in polymorphism which demonstrate how the behavior of methods can vary depending on the actual object type, like for example the tour or the hiker, and even when accessed through a reference of a parent type or the manageable entity. It explains that the methods used in both tour and hiker classes are from or has a reference from the manageable entity or the main abstract class. Since I have discussed the abstraction part here in polymorphism via abstraction, let's come now to the polymorphism side. The code utilizes polymorphism, a key feature of abstraction, to interact with tour and the hiker objects through their shared interface or superclass, which is the manageable entity. The implementation is for the display and info, like what I have said in the abstraction part, which is specifically to denote actual object type, which is for tour or the hiker when they are executed. Then it eliminates the need for separate logic to handle each data. The use of polymorphism here ensures that the correct display info method is called at a runtime, depending on the object's actual type without requiring explicit type checks. And that concludes the 4 pillars of object-oriented programming, which are the encapsulation, inheritance, abstraction, and polymorphism.
Hi, I am Tristan, and I will be the one who will discuss or demo the features of our system, which is the Thirst Hikers Management System. So let's start. So when starting the system, it will bring the users or the admin to the starting page or starting or the landing page. So in this page, we have a options. Um, We have three options: the admin panel, hiker registration panel, and report incident. So first, let's start exploring the admin panel. So when selecting an option, we just need to put their assigned numbers. So for this one, since the admin panel is in number 1, we need to enter 1. And then it will ask a password. So the admin is the only one who can access the admin panel because the admin panel have a private informations about the users, tours, and etc. And then inside the admin panel, we have a options, 5 options: the manage tours, manage hikers, search hiker, view reported incidents, update incident report. So let's start by exploring the manage tours. So inside the manage tours, we have a options, add tour, view tours, update tour, delete tour, back to the admin panel. So basically, this side is for the CRUD of the tours. So let's try these functions one by one. So first, let's try adding tour. So to check if it is already added, we can check it in here in this section in the view tours function. So yes, it is already added to the tours list. And then if we want to update a specific tour, we can just go in this section, in the update tour section. So we need to enter the tour code of the tour that we want to update. So in this case, we want to make changes to this tour. So let's try to change its name. So the other information, we'll leave it blank to keep the current. So let's check if it is updated. So yes, it is updated. And then next one is if we want to delete a tour, we just need to go to this section, to the delete tour section. And then it will ask the tour code of the tour that we want to delete. In this case, I will not delete this tour because I will use it later on for the registration of the hiker. So going back to the admin panel, now we will try to explore the manage hikers. So inside the manage hikers, you have a options: add hiker, view hikers, update hiker, delete hiker, and back to the admin panel. So first, we will try to add a hiker. So in this section, the available tours is already displayed so that the admin can already determine the available tours. So they can easily find the tour codes. So let's try registering tour in this tour code. So hiker name, age. So the hiker is already registered. To check if it is in the hikers list, we can go here in this section, in the view hiker section. So we'll by using the tour code, we can view hikers. So here, this is the registered hikers in this tour code. So next one, we will try to update hikers information. So let's try to update this information, Tristan's information. So here, it will ask a new name. Let's try to capitalize the first letter, then age, same, and then the tour, same tour. And then hiker is already, hiker is updated successfully. So let's try checking if it is updated. So yes, it is already, it is updated. So next one, if we want to delete a hiker, we just need to go to this section, delete hiker section, and then it will ask a hiker's name. In this case, I will not delete this hiker because we will use it later on. So going back again to the admin panel, we will now try the search hiker. So we will try to search hiker by entering their name, for example, Tristan. And then so the information of this hiker will display. So next is the view reported incidents. So in this section, it displays the reported incidents by the hikers. And then if you want to update the status of this incident, before that, this Y, it means solved, and X is for not solved. So let's try to update it. So the tour code where the incident happened, and then the current update. Let's try to make it X. So let's try if it is updated. So yes, it is updated. So going back to the hikers management system starting page, we will now explore the hiker registration panel. So in this section, it has three options: register for a tour, view hikers from a specific tour, and back to main menu. So basically, this two section, the admin panel has already it. But in this, this is for the hikers side. So they can register themselves, and then they can view hikers from a tours. So the last section in the starting page of this system is the report incident. So this section is for the user, so they can report incidents from a specific tour. For example, enter incident description, missing boy. And then this reported incident will appear on the admin panel, so the admin can see the reported incidents. So that's all the features of this system.